Okay, hello everybody. So as we said, we're Equillibrium.EXE, team 19458, and we're here today to talk to you how we can help you guys improve your software structure. So this presentation is kind of geared towards people who are either moving from blocks to Java and Android Studio, or who are just beginning their Android Studio experience. So we want to help you really take advantage of the fact that you're now using Android Studio to make your whole software experience a lot easier. So why do we want to do this? So there are several reasons objectives we have by improving our software structure. And the number one thing is that us as programmers are lazy, right? So we want to make our lives as easy as possible. So in order to do this, we can do several things. So by improving our code reusability, makes our life a lot easier because instead of having to write the same code tons of different times in tons of different places, we can just write it once and use it over and over again. We also want our code to be concise as possible, right? So if I can choose not to read 500 lines of code, I don't want to. All right, if I can do the same amount in 50 lines, it's a lot easier, makes life a lot easier for me, and will just make the code experience a lot smoother. And also by having these things, it makes it a lot easier for us to iterate as programmers, right? So if our programming is reusable and shorter, it makes it a lot easier for us to make improvements and changes, which makes our final product a lot better in the end. Additionally, good software structure can help you collaborate better, right? So having things like branches using GitHub can help multiple people work together on the same project. And modularity can also be part of that, right? So by having different parts of code in different places, not only can different people work on different parts of code, but then changes or breaks in one part of the code won't necessarily break other parts of your code, which is always helpful. And this also doesn't affect us just as programmers, it also affects like our drivers on the field, how we write our structure. So the most basic level of improving our software structure is just the organization, right? Because once you start getting to a more advanced level where you're in, um, you have lots of different files, different classes everywhere, right? The most basic thing you can do is just organize them nicely, right? So simple things like folders, where, for example, our auto folder, which has all the stuff for auto, like different auto paths, and our robot folder, which is very important. That contains all our different hardware subsystems, right? So if you see on the left-hand side, we actually don't have, it's not like we have one teleop class or program which has all the code that runs in teleop. Rather, we have a bunch of different subsystems which essentially make our teleop code more modular, right? So each of our different hardware subsystems are actually split into different areas of code.
Okay, so as Owen has mentioned, classes are the major way that we're going to organize our code. And this is because they have several benefits, such as being self-contained. So you can see here an example of a class that's called hang, which represents our hang subsystem on a robot. This class stores the state of the hang, the servos that are needed to run it, as well as the positions of those servos. And the benefit of being self-contained is that once we import this hang class into our teleop or auto programs, we can then change anything that we need in the hang, such as the positions of the hang or the servos that we want to use for it, in the hang class, and those modifications will automatically be made everywhere else we use the hang. Next, we can also define methods within the hang class, such as this method, which moves hang to the up position. Methods work the same way in the class as well. We can edit the uh, code that makes up the method, and that allows us to switch the functionality within the class itself and everywhere else we call that method. And once we import the method from the hang class to any of the auto or teleop classes we use the hang in, that method can also be called within those classes, preventing us from needing to rewrite that method. And finally, classes are also swappable. This means that we can define a bunch of auto or teleop classes instead of relying on just one class where we need to rewrite or overwrite code in order to make changes to functionality. We can have several ones that we can test out and choose on the driver hub. However, this does create some clutter, and we'll tell you later on how to reduce this. Aside from classes, there are several other ways to improve your software workflow, such as using classes or importing those classes both in your teleop and auto. So let's say that there's a subsystem on your robot, such as your hang, which works similarly in teleop as it does in auto. you can extend or import that class both in your teleop and auto, and that allows you to reuse that code with the same functionality without needing to program it both times. Next, you can also organize your code based on alliances. You can define variables for alliances or positions and write different paths for your auto programs based on those positions and alliances in the same class. And this system basically allows you to choose which path you will follow based on the alliance and position that you set without needing to program, let's say, 4 different auto uh, classes for all your autonomous paths. Finally, we also want to reduce branching in our code, and that means after you make a decision in your code, such as getting a purple pixel versus getting a yellow pixel, if there's a action that we want to take after that decision, and that is the same for either choice, whether it be choosing the purple or the yellow pixel, we want both those options to point back to that final action, which is depositing the pixel. So you can see on the example where we have branching, we need to program that deposit pixel action twice. And on the side where we don't have branching, both those options go back to the deposit pixel action, and we reduce the amount of code we need to program. Finally, here's just an example on how to define a class, create a method, and import the class. So you can see we have a class called hang at the top here, and a string within that class that has the motion of the hang. Then we define a method called move that prints the motion. And finally, we import that hang class into a different class called robot, and we can use that method in robot as well without needing to reprogram it. Next, we'll have Miriam talk about how to organize your code with Auto.
Yeah, so as you can see from that picture, auto, yes, you can just have a bunch of different op modes, but it creates a decent amount of clutter, similar names, like for example, blue left, blue right. Your drivers are under a lot of stress at the field. They might accidentally select the wrong ones. Not saying they will every time, but it is a possibility. And then also it's all programmed separately. Like there's a chance that blue just place has you might want some to share some code with red just place, but if it's completely programmed in separate op modes, there's no good way to do that. And so one solution to this problem, the one that we used is we actually use a JSON file in order to store everything we want to know about our auto path. So JSON is JavaScript object notation. It's just a very common file type, super easy to parse in Java. We use a library called JSON, which is included in the FTC SDK. There are other ways you can also do it, and it's just overall, we find that it is a good way to store data. So now the reason why JSON can be useful in FTC is because we have this program that will populate JSON files. So what happens here is we wrote a program that will guide you through each possible option that you have, and you can use the gamepad to make your selections. And now the great thing about this is that it's not like each possible JSON file you can have has a different path. We have some if statements in there and switch statements to say, okay, well, if I'm blue, do this. If I'm red, do this, and then it will just go back to doing the same thing. So it's non-branching, like Ivan talked about. It only differs in places where it needs to differ. And then the result of this is once you've populated the file, all that your drivers need to do on the field is, next slide, all they need to do on the field is select which JSON file you want to use. So you can see you can create multiple JSON files, and then And then what you do is you can scroll through them, you select which one you want, and then you have everything that you populated earlier because you can run that step in the pits. And then it is super easy to just like load everything quickly. And that's all your drivers need to think about. They just need to know which match it is effectively. And that's all super simple. It has worked very well for us this past season, and we hope it can be helpful to other teams out there. So thank you everyone for watching, and we will now take any questions.
All right, I think let's start with some online question that we had. One is from Pranav from FTC 23425. He said, is it possible to get code from Android Studio directly into a GitHub rep?
So the answer is yes. So you can get it directly into a GitHub repo. I depends on what you mean by directly. Like you still like it's not going to be like automatic or anything. So this is getting into a little bit of how Git works. Basically you have to commit your code locally, and then once you've committed it, you can push it to GitHub. And then you can later from another machine, or one of your teammates can do what's called polling the repo to get it their updates onto your local machine. I think GitHub is a little bit outside the scope of this presentation, but there are plenty of online resources into how Git works, and I would recommend that you find an online tutorial.
All right, thank you so much. Then we'll go next on to in-person. Is there anyone in person having questions? All right, if not, then it seems like we have a few more online ones. Melanie from team FTC 23493 said, we're trying to move from onto Java, from Onbot Java, I assume, to Android Studios. What's the best way to teach classes and objects in relation to FTC?
Yeah, so I read the question. The best way, I don't think there's like one set like example that'll really make it click for everybody, right? But the biggest way that I think to really learn how to understand Java, and especially for FTC, is really just looking at a lot of public team repos, right? There are tons and tons of teams out there that have that publicize their code, and that can be really helpful. But also for learning more simply about how Java itself works, not necessarily for FTC, but just generally how classes and objects works. There are particularly good websites out there that are mainly geared towards the AP Java, like the AP Java curriculum. But there are many websites out there that are then very good for teaching like all about Java.
All right, thank you. I think we have one last question. And there was two more in the chat. I was wondering after you guys, as we move on to the next presentation, if team members from Equillibrium.EXE can reply to the remaining two questions in the chat, but we have one last one. What was the JSON parser library you mentioned?
So the parser library that we have used is called GSON, so GSON. It's made by Google. It is actually bundled into the FTC SDK, so you can just use it. You don't have to import anything into Gradle files.
All right, thank you so much. Let's give it up for Equillibrium.EXE.